Welcome to the official launch of the eFabless Chipalooza 2024. I'm Tim Edwards. I am the Senior Vice President at eFabless in charge of analog. And I have been a big part of the architecture definition of the eFabless Caravel chip and a big part of onboarding the Sky 130 Open PDK and the GF PDK, although this particular challenge is going to be on the Sky 130 process. So welcome, everybody. So what is Chipalooza? Well, if you've seen events that have this suffix palooza, it comes from this odd word, Lollapalooza, which is a North American slang term for an extraordinary person or thing. So just in the same way that Chipathon puts together Chip and Marathon, Chipalooza puts together Chip and Lollapalooza for what we hope is an extraordinary event. Yes, but okay, etymology aside, what is Chipalooza? All right, this is the first eFabless Challenge event for open source analog and mixed signal design. I should qualify that statement a little bit. About, I guess, 4 or 5 years ago now, we had a challenge that was based on our platform for XFAB for doing analog design. It was partially open source, so I would call this the first eFabless Challenge event for a fully open source analog and mixed signal IP design. And the structure of this challenge is going to be very similar to the AI challenges that we did very recently. And that means that there will be requirements, there'll be reviews, there will be deadlines, and there will be awards. And why are we running this Chipalooza challenge? And the big answer to that is that we have been very successful now with the Caravel harness chip. And that program has been going on for a few years now, and it is time that we define the next generation version of that. So everybody talks about AI and edge IoT and machine learning. Those are the big buzzwords of today. And there are some very successful SoC type products that target this space. And applications on those kinds of SoCs need to interface to the real world. And that means those kinds of SoCs have the kinds of resources that the designers are going to want. And that includes ADCs, DACs, instrumentation amplifiers, sensors, filters, power monitors, and so on. All of the kinds of analog that are really the core of analog design, and people who take classes in analog design learn how to do this stuff. It's all the very basic stuff. Nothing fancy or unusual here. But let me give you a quick sneak preview of what we're planning for this upcoming Caravel harness chip. So this picture here is what Caravel looks like now. If you are familiar with the ChipIgnite program, you know this Caravel has 38 GPIOs available to people who design and put their design into the user project area, which is in the middle of it and gives you 10 square millimeters of space to work in. And at the bottom, there is a SoC RISC-V microcontroller. So this is what the new one's going to look like. And as you can see, the pad frame is a lot fuller. So this is a pad frame with 128 pads, and 66 of those are going to be GPIOs given to the users. There will be dedicated analog IOs, so I don't have to go define another chip called Caravan like I'm doing right now for analog design, but people should be able to use the same chip for both digital and analog. And for all those people doing SoC, doing IoT type applications in that user project area, we are going to have all the stuff that I just mentioned that is what they want to see, which is ADCs, DACs, and every sort of analog subsystem. Obviously, none of that has been defined yet, which is why this is all just a big block diagram inside a mock-up pad frame. So we want designers to be able to make use of those resources as soon as possible. Realistically, that's going to be sometime in 2025. If things go well, early 2025. We're going to have to design a test chip. There is no way we can get a test chip designed until, say, the June tape out, and then it's going to be a few months before we get that back and can test it and get that turned around as a project that people can submit on eFabless, their user projects. In that time, between now and a supposed June tape out for the test chip, we do not have either the time or the staff to develop all of the required analog and mixed signal IP that we want to go on this thing. So we're asking our very large and very fine community of analog designers to help us out here. So what do you get out of participating in the Chipalooza? Well, for one, all the designs that are submitted are going to be open sourced. They'll be available for other designers for education, reference, reuse, and enhancement. I'd like to make a parallel here to Thingiverse. If you're familiar with the world of 3D printing, Thingiverse is a similar repository of IP for 3D printed stuff. And I can say that the people who were the early adopters of Thingiverse and joined and posted the first 1,000 or so things that went into Thingiverse are probably the most cited, most referenced 3D printed designs in the world. So if you are an early adopter on the right platform, you can get a lot of good press out of doing that. In addition, the best design for each of the required IPs that we want will go out on the next generation Caravel test tape out, the one that I just mentioned with the 128-pin device, and that'll be in June. However, before then, the designs that make it through the post-layout design review and pass all the specifications that we require will be integrated into the ChipIgnite slots, and they'll go out on the April ChipIgnite shuttle run. And since that will be just a standard ChipIgnite run in April, the designers will get back the development board and assembled parts. And we hope that with those assembled parts, you can do some characterization on the design that you made. And there will be awards. So awards in the form of free silicon. Everybody here likes free silicon, right? And a t-shirt. It's about time that we made a t-shirt. We have not done that before, and I have no idea if the t-shirt's going to look like this. This is what I came up with in 5 seconds of work, but we'll give out a t-shirt. And there are rules. Of course, there are rules. So here are the rules. So first, eFabless is going to provide a list of the IP blocks. So it's not like we're asking you to design and define whatever you want. We know exactly what we want, and we have a target specification and a target pinout. And there is a list of that. The actual spreadsheet with the IP and specification is in a Google Docs with some hash code URL, but you can get to it from a link that is in this URL here at efabless.com, analog and mixed signal design challenge, and Andy or Andrea should type that into the chat so that you can see it, copy paste it if you want, and then you can follow along when I show it later on. So requirement number 2, participants will write a proposal. So what goes into this proposal? It's going to consist of telling us what block you're planning to design, what architecture you're going to use for that block. You'll note which specs are very challenging and how that architecture will meet those specs. And you need to demonstrate that this design is feasible within the Sky 130 process. Now, we are not necessarily experts in every single kind of analog design out there, so we have done our best to define what the spec should be for these blocks, but there is always a chance that what we have designed, especially for like the pinout, is not exactly what you need. Maybe to meet the performance, you need to add some number of trim bits. So you may depart from the pinout by adding additional pins for digital, for instance. If so, you just need to note that, and we will need to approve it. I wanted Andrea to add, now that you know what the starting point is, I'd like to do a quick survey of just to get and also since now 120 or so people have joined, to get a poll here, which just popped up in the middle of my slide, of who is planning to submit a proposal, who thinks they might, but they're not sure yet, and who's certain that they're probably not going to. That will give us a good idea of how many proposals that we can expect to get, and that gives us a better idea of how to plan for our upcoming chip. So requirement.
There is a question in the background from anonymous attendee on what are the designs that we can do.
Sorry.
What are the designs or IP blocks that we can do?
Yeah, don't worry. I'm going to go through that. Whenever you make a set of slides like this, you have to figure out what order are you going to present all the material in. So as it is, I've got the IP. I will go through all the IP blocks. That's going to be at the end. So just hold on a little bit and all will be revealed. So after we get the proposals, and I should mention here, we had not mentioned, I think, anywhere in the existing documentation what form we would like the proposals in. I would like to have the proposals done in PDF format, and they can be emailed to shuttle@efabless.com. You can also post them to me at Slack. Either way, we will get them. And there is a Slack channel that is going to be devoted to this. So all information, if I need to clarify anything, I will be posting to that. Was also planning to show that on a slide later on. But at some point, and again, the timeline is another thing, I would like to present all these things at one time. Right now, I am just going through the requirements, and then I will go through the timeline and then the actual IP. So the proposals will be reviewed, and at that point we will select participants. In order we do not want to have like 20 participants doing one design and the other 19 designs without anybody. So we are going to try to do up to, say, 3 designers or design teams for any one IP block. However, designers may submit multiple proposals. You may even want to get on the Slack channel and work it out among yourselves who's going to do which IPs, because the overall goal here is not to find the winners. It's to get the coverage of all this IP that we need for the next generation Caravel. So we will be happy if we can cover all of the IP. And not have to reject teams because too many were trying to do one specific IP. So the next step of that, once you have made a proposal and we have accepted it, then you'll create a public Git repository for the project. This is very similar to the way that we do the Git repositories for ChipIgnite, except that in this case, it's not going to be a full ChipIgnite user project. It is just going to be a single IP block. There are Git repository examples that I will eventually point to in the Slack channel where we get information. So this Git repository must contain all of the required design files, and we will specify the file system structure, that is what directories you need in the repository. That is not to be annoyingly restrictive, but just to make sure that we have consistency across all of the IP blocks, because at some point at the end of this, we need to put this on some ChipIgnite runs to go out in April. We'll have about a week to do that. And so if everything is consistent, everybody has the same files and the same directories, then that makes it a lot easier on us to get it done in time. Designers will use open source tools for the design. Now, this is the requirement that is likely to make more people unhappy than any other requirement, but there's a good reason for requiring open source tools, not just that I'm a developer of open source tools. It's that the open source tools ensure that anybody can reuse the IP. Once this IP goes up and is public in GitHub, then if anybody wants to reproduce the results of the characterization on that IP, they can find all of the tools that they need to do exactly that and get exactly the same results. And as a side benefit, by using all open source tools, you ensure that all of your publicly posted files in the design repository are absolutely legal. Requirement number 6, schematics will be subjected to design review. So at the point that the schematics are due, the test benches must also be available, and which simulate all of the specifications. There are a few specifications like long-term stability, which are not simulatable up front. Those do not have to be simulated. Everything else does. All test bench results must meet the specifications. We will require graphs and minimum, maximum limits and so on that show that each of the specifications has been met. And again, like I said about the pinout, we cannot anticipate everything needed on this IP. We're not necessarily experts in every single IP. And so there may be occasions in which specifications we have put up are unreasonable. And if that is noted by the design team, we can review that and correct it by agreement. But that needs to be prior to the schematic design review. Requirement number 7, the final layout will be subjected to a design review. So at the point at which the layout is submitted, the test benches must simulate all of the electrical parameters in the specification on a parasitic RC extracted layout. And all test bench results must still meet the specifications. There will be some requirements and some design guidelines on the layout, and we may judge layouts for deciding which of the IPs, if there is more than one, which one will eventually go out on the Caravel test chip. The better the layout, the better the specs are met, the more likely that that will be the project that goes out in June. So an example of the requirements is that the layout will have to be in a deep in-well structure with double guard rings around the entire block. There are others. They will be posted. I should post them, I think, later today on the Slack channel. And as a design guideline, layouts must be reasonably compact. Reasonable is a wishy-washy concept, but I, for instance, don't want to see large amounts of white space in the middle of a design, because every bit of white space in the middle of a design is space that could have been put into the user project. We will be specifying some area requirements, however, without knowing exactly what the size of what the circuit architecture looks like. It's a little hard up front to make estimates on the layout area, so we will probably be putting those layout area requirements up later after we've seen the architectures and have a good idea of what the layouts ought to look like. Requirement number 8, all designs that pass all requirements and design reviews will be integrated as a standalone circuit on the chip ignite slots on the April 24th shuttle run. That's not really a requirement for you. That's just a statement that April 24th for us is a very hard deadline. That is the shuttle run close date, and that is why our timeline for this is relatively short. And yes, I said there are deadlines. And you might want to be seated before viewing the timeline because it is quite short and may make you feel a little woozy. This is the full timeline. As you see, it covers the time between now and the April 4th tape out. April 24th tape out is not long. It is already mid-February, so we have half of February, we have all of March, and in order that we have some time for layout integration at the end, then the challenge is going to have to end in mid-April. So that's 2 months. Now let me break down this graph here into parts. So today is February 16th. This is the challenge launch. This is day 0. We are giving you 2 weeks to get a proposal submitted. So there's 14 days from now until March 1st. Following that, you got about 4 days until we do the proposal reviews and accept it. We hope 4 days is enough for us to go through. It depends on how many proposals we see. We will do our best to get that done in 4 days. And I want to have some workshops so we can help you through this whole process. We want to make sure that anybody who's not comfortable with the open source tools or just needs a little help getting through that has a workshop where they can get examples and tutorials on how to do it and can ask questions and get answers. And I want to put that as close to the beginning of each phase of the challenge as I can. So this one is going to be 2 days after we have accepted reviews. Now, if you know what you're doing and you're comfortable with the schematic tools, you can start working on this as early as March 1. Again, that's the risk of you to decide whether you have a chance of getting accepted, which really depends on the number of proposals being submitted. So from there until the schematics are due, that's going to be another 15 days, 2 weeks. So the total time from the time you submit your proposal to the time the schematics are due is 3 weeks. Following that, we do schematic design reviews. You might get a few extra days because we're going to have to schedule out these reviews over the course of 3 days. And so if you get a late design review, you might have a few extra days to work on it. But that is up to luck. Following the schematic design reviews, we will do our best to try to get everybody through the schematic design review stage. I do want to keep reminding you that the goal here is not to find winners and losers. The goal here is to get working IP and get it up in public and get it onto the June tape out. So a few days after we have gotten people through the schematic design review, there will be a layout extraction workshop where we will help you through the layout tools and how to do full RC extraction. And after that, within a week, there will be another workshop to show you how to do all the physical verification. And again, I'm trying to push those up front toward the beginning of the layout phase so that you get the instruction that you need before you actually have to be doing the layout or at the same time as you're starting. And then you got another 2 weeks. So another 14 days. Layout is due on April 15th, along with your taxes if you're in America. And that gives you 23 days or just over 3 weeks to do all of the layout and verification. Finally, after that, there will be a post-layout design review. We got a couple of days to work through that and schedule that with all of the teams. And following that, the April 24th shuttle run is just a week after, and that shows you just how little time I will have. And it's probably going to be me putting together all of these designs as submitted and stick them onto ChipIgnite slots to get them out the door for the tests. And there are awards. So here are the rewards. All the designs that have accepted proposals. So if you get through the 2 weeks of making a proposal, submit it, and we accept it to go in for the rest of the full challenge, you will get a tiny tape out slot. That is a $300 value. If you want to see the details of the tiny tape out project, you can go to this URL here at efabless.com/tinytapeout. And upcoming tiny tape outs will have the ability to take people's analog designs, something new that Matt Venn has been working on. All designs which pass the schematic design review and still meet all the specifications will get another tiny tape out slot, which is another $300 value. And finally, all designs which complete the full post-layout design review and still meet all specifications will get a free quarter ChipIgnite slot, which is approximately a $2,500 value. And free silicon itself is just hard to come by right now. As you know, Google stopped doing the open MPWs, and so it's hard right now to find free silicon, and we're offering for a little bit of work up front, free silicon for you to do whatever you want with. So there are no requirements on that slot. You get that, it's yours, do whatever you want with it, knock yourself out. So finally, back to the question that was asked early on, what are the IP blocks that we want? Here is a quick overview. I'm not going to go through every individual block for lack of time, but breaking this out into about 4 categories here. So the first thing we want is signal processing. So we've got a resistor DAC, capacitor DAC, and a current DAC. There will be an ADC. Now the specs on these, roughly, the resistor ladder DAC is 12 bits, the capacitor DAC is 16 bits, and the current DAC is also, I believe, 12 bits. The capacitor DACs won't hold a value. They will have leakage. They are typically used for AC purposes, like being the front end into an ADC. Resistor DAC will be something that you can connect directly to an output and will hold a value. Current DACs are an interesting species of DAC that you can do current sources or sync. They're designed very differently from the others. A rheostat is another kind of DAC. It's basically a end-to-end resistor with a tap in the middle. And the hard part of that design is that you need to make sure that you are tapping out at a particular resistance, including all of the parasitic resistances that you're going to get through all of your switching muxes to the end. There will be several versions of op amps. So we have thought about this quite a bit. We have broken it down to 2 basic op amps, one of which is going to be a preamplifier, such as for a microphone, but also used for motor sensors. So the range for a microphone would be 20 kilohertz, for motor sensors about 50 kilohertz. So that's the kind of bandwidth for this op amp, not high drive output. There will be another op amp design that we want, which is a general purpose operational amplifier. Will have higher drive output. There'll be, let me skip the Salon key filter a minute. There'll be comparators of 2 different kinds. There's an ultra low power comparator, the sort that you want to have running when the whole chip is in a hibernate state, so that it can run on a very low power overhead at very low current, and will be watching for some event happening off chip. So when some off chip signal hits a particular threshold, then the comparator will trip. That will wake up the rest of the chip, and it will boot up and do some sort of signal processing. In addition to that, there'll be a standard comparator, a high precision comparator that runs at higher power, but is one that you can turn on and off. The Salon key filter, the ADC and Salon key filters are relatively complex designs compared to just about everything else in this list. For the ADC, the complexity is mitigated somewhat by the fact that you can assume that the CDAC is feeding the ADC, and the CDAC's being defined by somebody else. You can use a placeholder for that. The Salon key filter is one in which you have essentially a programmable filter, which is a collection of op amps, and probably it would need to be a switch capacitor design. So you have banks of switches, you have op amps, you can configure them in multiple different ways to make low pass, band pass, high pass filters in Bessel or Chebyshev or Butterworth configurations at first or second or maybe even third order. This is not a well-defined block, and it is not one that we are considering mandatory to go out in June, but it is one that we're very interested in. And if anybody were aggressive enough to try to define this and design it, then we would certainly take it. Second category is power management. So much of this is supporting all of the other categories of IP on here. So there is a band gap, which is going to distribute a band gap voltage around the chip, as well as scaled down band gap voltages such as 1.024 volts, which is often used for input to DACs. This is supposed to be a low power band gap, and we want it to run at 1.8 volts, which means that we are not going to rely on the 1.8 volt external input to the chip, which means it has its own LDO. So the LDO here is a very dedicated low power, limited bandwidth LDO, which exclusively services this band gap. There is a power on reset on the existing Caravel. It's a quick thing that I designed a long time ago, and it's one of two different types of power on resets. You can build a power on reset that is either based on a band gap and is looking for a specific voltage threshold, or one which simply delays for a certain amount of time, and you hope that the power supplies have come up by the time that that time expires and it trips. So that's the kind. The second kind is the kind that I designed, and I would like to see one which is based on a voltage threshold that is produced from a band gap. So there is the power on reset. Similar to power on resets are brownout detectors and overvoltage detectors. They're pretty simple circuits. I don't think I need to spend much time explaining them. The bias generator I should probably have mentioned when I mentioned the band gap, because the idea is that the band gap creates a voltage reference, a band gap reference. The band gap reference then immediately goes into the bias generator, which generates currents that are based on the band gap voltage. So they are very constant currents, stable over temperature, and those are distributed throughout the chip. And there is in the specification of the pinout for almost all of these other IP blocks, a I bias, which means that if you have a need for a voltage or current bias, you will pull that in as a current bias from this bias generator. You can just assume that that exists and is stable. And then that becomes the bias input, which prevents you from having to do your own, say, resistor bias, which would have issues with maintaining a high PSRR. With the band gap related current coming into your chip, to your IP block for a bias, you can get high PSRR. A slightly smaller category, which could contain the voltage detectors over here, is a temperature sensor. Very useful thing to have, fairly standard. Well, there are various different ways to do temperature sensors. Choose your architecture, meet the spec. And finally, a class of oscillators. These are not circuits that are for the use of they don't go into the output of the analog part of the chip, but they are going into the timing part of the chip. I don't know if you remember back to my block diagram of the next generation Caravel. The analog IP that was up at the top of the chip is all this other stuff, mostly the signal processing and sensors. Down at the bottom, you have the oscillators coming from crystals outside the chip, and they go into a timing management circuit that is part of the POR. And we have a low-speed crystal oscillator at 32 kilohertz and a high-speed crystal oscillator at 4 to 16 megahertz. And if you know the Caravel architecture very well, you know that I designed a interesting digital lock loop for it. It works really well. The problem with a digital lock loop, at least the way I designed mine, is that it has very high phase noise. So people who are doing any circuits depending on low phase noise and the clock timing can't use that. So a very nice PLL would be a very useful thing to have on the chip to replace the DLL that I have now. So altogether, there are 20 circuits. A few of them were multiples. Like I said, there were 2 different op-amp types, 2 different comparator types, 2 different crystal oscillator types. And the full list is on the link of the page that I posted to a while back. If you go to that page, then there's a series of tabs. So there is a summary page, which tells you what all the IPs are, and then a page for each of the IPs. Each page looks like this. There is 3 blocks. You've got a description up at the top. You've got the IP name, description up at the top, then a set of electrical parameters. So this is the challenge, is to meet these electrical parameters. It tells you what is the minimum and maximum limits for various things like PSRR, CMRR, VOL, VOH, all the normal things you expect to see. It's all what you would typically see on a data sheet of an IP block. And that's the spec for your circuit design. And then the third block is a pinout. And most of these are going to be mandatory. As I said, if you have extra trim bits or so that you may need to add based on the particular architecture you've chosen, you can make those kind of changes. But otherwise, we are specifying this is your power supply. It's coming from the analog power supply at 3.3 volts. This is the digital supply. It's coming in from the digital power supply at 1.8 volts, and so forth and so on. Almost all of the blocks are going to have enables, this being a chip for low power operation. We want to be able to have users turn off every single IP block that they are not using. And that is why there's enable signal on all of them. And as I mentioned earlier, there's a bias current distribution throughout the chip. So each of these can optionally take a bias current. I expect that in order to meet some of the PSRR specs, that the I bias is essentially going to be mandatory into these blocks. So I have referenced this Slack channel from the beginning of the talk. So this is where you go. It is on our Slack workspace called Open Source Silicon. And the URL here, www.opensourcesilicon.slack.com, is where you go if you already belong to it. If you do not already belong to it, which I expect most people on this call probably already do, but if not, you can go to the efabless.com website. On the front-facing page, up at the very top, there's a bar, and at that end of the bar, there's this button. It says Slack. Click on that, and you get a registration page to join the Slack community. There are literally thousands of people on this Slack workspace, and if you are not part of it, then you should be. So come join the discussion there. And I'm creating a new channel in that workspace called Chipalooza. And that is where all of the discussion can happen. If you have any questions, I will be monitoring that channel regularly. So I will be happy to answer questions that anybody has. And I will, from time to time, post any updates or clarifications that people want about the challenge and how it's being run, deadlines, and so forth. So I want to thank you for participating in the webinar, and I hope to see you participating in the challenge. So now you can go and start designing. And at this point, I can open it up for questions and answers. If there are questions that have been queuing up on the Q&A window, I can sort of monitor them over to my left here, but let's see. If you want to, if Andy, you have probably been watching them, so if you want to feed me questions.
There are many. I'll start at the top. So the first one, which is what are the designs that we can design, I think has been well answered.
Okay, yes, I hope so.
I'll click down on that one. The second one was, can Chipalooza be used in military applications? There are very obvious legal restrictions that prevent eFabless and Skywater from shipping silicon to certain applications. So the answer is casually no. At the same time, if somebody was to take the IP and validate it through the appropriate business processes and military certification processes, it is possible that somebody could choose to use a piece of IP that originated in the open source that way. It is very, very unlikely today that that would be their chosen source of IP, because there are plenty of vendors that service the military, industrial, and complex today. So I think I answered as generally broadly and as clearly as I can.
Yeah, 130 nanometers is a good space for analog. It is not particularly a good space for high performance stuff, and so it usually doesn't attract the attention of like ITAR restrictions and so on.
Exactly. And do we have suggestions for open source tools? The answer is yes.
Yes, we do. Yeah, maybe I should have snuck in a slide on that. In fact, I thought about doing it and then thought that getting all the screenshots for that would be a bit of work. So for schematics, we definitely, I think everybody now is using Xscheme. And for layout, we suggest either Magic or K-Layout. For simulation, we suggest ngSpice. I know some people are using Zeiss. For the most part, any open source software you want to use, as long as it is possible to go to GitHub, download it, and run it. As I said, the main goal here is that stuff up in the public repository, anybody can pull it down, find the tools, run them, and get exactly the same results as you got. But we do have our recommended flow, and it is Xscheme for schematics, Magic or K-Layout for layout, ngSpice for simulation.
And there are a couple of quick answered questions that I wanted to run through. The pure GDS2 question from Mark Anderson, the answer is not just pure GDS. We need to supply schematic, the layout, the simulations, the test benches, the data to be able to reproduce exactly what you generated for those logs and data sets. It has to be in the submission. So this IP has to be usable in the open source community, not just a hard layout instantiation. Which CMOS node to Faisal? The answer is Sky 130A. So it's the Skywater Sky 130A technology. To Art Scott, a quarter slot is 2.5 square millimeters. Whereas the Slack channel has been asked about 6 times, so I've posted it, I think, to everybody who asked the question. There are still 30 more questions, so we've got to get through them at about one every 30 seconds to get there.
Well, that's okay. We got plenty of time. I made it relatively short.
PLL spec has a jitter spec. How can we know if we can meet that when we don't have transient noise simulation support yet? That's a good question from Tom.
Yeah, that is a good question. You should be able to not necessarily simulate it, but if you know, well, let's see, for a PLL, that is a bit harder. It was actually easy for the DLL because I could do it numerically.
Yeah.
It was just a matter of taking statistics on. Yeah, good question. We will probably not be terribly restrictive about that spec. So
I think we can look at edge rates inside the oscillator and look at systematic jitter components in the simulation for post layout. But I think he's right about not being able to answer phase noise components from the oscillator itself.
Yeah, I agree. I agree. Phase noise is
nice catch, Tom. Thank you. How many members in a team from anonymous attendee? Up to you. If you guys are able to form teams and adjudicate between yourselves how to award the prizes or the silicon space, we are very happy to work with small teams. You'll have to figure out how to interface to us as one person. So that's going to be a little bit complicated. We need one account to be able to do the submission from GitHub.
Yeah, so yeah, we'll need one GitHub account, but multiple people can input to that GitHub. You can have multiple developers.
And next, also from anonymous attendee, what's the proposal format, APA, etc., to adapt for written documents? Do we have a template?
No, I don't. It is one thing I was considering. I had not had time to work on, and I was thinking of putting that up in the next few days.
Okay.
It's probably going to be more of a guideline than anything else.
Okay. Anonymous attendee, what are the chip design norms, ISO, etc., and standards IEEE that the eFabless recommend while adapting the project life development cycle process? Regards. So we are not currently specifying a chip development ISO or IEEE development standard. We're specifying a review process through the development cycle. It's going to be used to develop this IP for the open source. There are several standards. Thank you for referencing two. Both ISO and IEEE have silicon design lifecycle standards that are normally aimed at a full product rather than an individual IP block. I think most of our users will be well guided through the proposal. and there's a specification, a review of specification proposal, a review of schematics, a review of layout, and a review of post-layout implemented simulations. So I think the pre-tape-out phase of a normal silicon life cycle is pretty well covered there. I think the post-tape-out phase has not been well defined yet, and I do think we need to have a conversation about characterization and bring up.
Yes, and as far as things like HTOL, HAST, those are things that are to be done on the full chip. That would be our job to characterize the full Caravel chip, as opposed to being done on an individual block.
Also, anonymous attendee, if I am to design an ADC, for example, that I will be using in my PhD dissertation, can I ask you not to make it open source until after I publish my main paper, surely after tape out? And that, I think, is very challenging because we can't go through the review process without it being open sourced. It's an open quorum.
Yeah, we would probably have to say no in that case.
I think that's very difficult to do to the anonymous attendee with the ADC idea. I apologize. Will we be able to access or attend workshops even if our proposals do not pass?
Yes, absolutely. I think these workshops are going to be very helpful to anybody doing analog design. They're going to be very basic instruction on how to use X-Scheme, how to use Magic, how to use how to do DRC, LVS, and RC extraction, things that people ask all the time. Absolutely, you're welcome to join. It will be posted as an announcement on our main page, so everybody will see it.
To Faisal again, what if our layout needs drastic changes post-layout? If we have significant problems with our design, will there be schedule impact?
There will be, as I said, there is a point at which the goal is to get the IP done. If there is a competing IP all ready to go, then you may be out of luck. If you're the only IP that we have, then we may be willing to work with you to keep pushing forward. And in that case, if it misses the deadline, it misses the deadline for tape out. But again, we will need the IP at some point. It's a judgment call. It really depends on how badly are you missing the spec. Are you just missing the spec by a little bit, or are you talking about a complete redesign? If it's something that looks like we can just give you a little help and push you over the finish line, that's what we will do, and we'll do that for everybody. Whether it's at the schematic stage, or at the proposal stage, or at the layout stage. If it's just like a little push, we'll help you get there.
I'm going to skip past anonymous attendees' next two questions. There's another one. Is there a participation certificate for people who get past the proposal phase with the blueprint?
I hadn't even given that much of a thought. I know that eventually when we have these things in a public repository, there's going to be more than just the Git repo, because we have a eFabless catalog, and so we will have a copy there, and that has certifications on it. I'm not sure that's the kind of certification you're talking about, though.
I think that this question was aimed at a PDF document or a picture that kind of recognized the initiative of somebody getting to the point of a past proposal. Best I could tell from the question.
Well, certainly everybody who is getting a design in we are going to publicize it well. Yep. You will get plenty of recognition.
Is there an opportunity to do DC to DC power management circuits? From Filippo.
Generally speaking, no. We have decided that for this Caravel chip that we are going to have our 1.8 volt supply external like we have currently, and not try to do a DC-DC conversion on chip.
Filippo, I'm going to give you a suggestion that's not particularly targeted at this specific Chipalooza. We are interested in some separate development of DC to DC circuits. I might get Tim to talk in the next webinar briefly about some proposed options for those circuits. so that we have an opportunity to do something. It won't be targeted at the next generation Caravel, but generally in providing the IP for Sky 130. Okay, so it's probably not going to be along the same lines as this Chipalooza with the same deadline. Okay. I think I can bring that up in the next review. So Tim,
that makes a lot. Yeah, that's a good answer.
Different deadline, Filippo, and probably be 3 months later.
Yeah, there will be more definitions. There will be more challenges. Right now, we're trying to restrict this to what we have, and this is the 20 IP that we've decided is going to define what we believe is the right chip to be taping out in June, so that it can be used by designers in the future.
Are the candidates allowed to use external preset add-ons, plugins, APIs, or utilities for chip circuits, blueprint, prototype models, etc.?
If they're open source, I don't see why not.
Okay, skipping down one. Should the analog filter be a switch cap? Does it have to be synchronous? Can we use other filter topologies?
Yeah, as I said, for that, it's so undefined right now. Send a proposal.
Yep.
Yeah, everything is possible. Generally speaking, I think that only a switch cap architecture works in that context. But send it, as I said, send in a proposal. I'm willing to take a look at it, see what you're proposing.
I don't know if I've got the name the right way around. I've got Omar Saleh, I think, or Saleh Omar. The question is, are we free to choose any value of the I bias? The answer is no. There will be a specific set of I biases, and you can generate multiples of those internally with a current mirror. But we will provide the I bias design or definition in the next couple of days. Remind
me to do that, because
it's likely to be something between hundreds of nanoamps and single-digit microamps. It will not be more than low single-digit microamps. Okay. Okay. Spencer Bowles, in the sheet, is the criticality of 1 the most important?
The criticality is, take that with a grain of salt. It was our way of organizing it to decide what was most important to us. As in the end, these 20 IP are all important to us. And as I said, it really depends on the number of proposals, the number of groups, how much overlap there is. Yeah, I don't know if you want to say anything else about what we consider critical, Andy, but
no,
but really, yeah, it's just we want these 20 IPs, and they're all critical to us at this point.
Link to setting up the tools after a 3-year break. There are 2 links. One is to a complete tool suite from Harold that is actually posted on the Chipalooza Slack page, which I hope everybody's got by now. And then the other is the Getting Started page for eFabless. So literally on the eFabless.com homepage, if you click on Getting Started, it'll literally walk you through with 2-minute video increments how to get your design environment set up and how to get your tools installed. For the proposal, do we have to submit an analog design only or proposal? Do we have to submit the design, or only the proposal will be enough for the first step? The answer is only the proposal for the first step. Do candidates have a right to submit more than one proposal along with the blueprint or prototype chip circuit design? I think circus is circuit. The answer is yes, they can absolutely submit more than one.
Yes, I said that on a page somewhere back then. I said submit however many you want. Oh, I should also mention, if you are submitting multiple proposals, do indicate to us what your preference is, because I don't want to just say, oh, we didn't have enough room for this, and toss out your favorite design. I mean, obviously we will base it somewhat on the quality of the proposal, but you probably want to say, okay, this is the one I really want to do. These are ones that I am proposing just in case.
Pradeep asked, how did we come out of with the idea for this? It's just awesome. And we have some fantastic board and consultant members who were part of the founding team of a company called Top Coder, and they ran an initiative like this for software development. And we're leveraging their knowledge, experience, and ideas to help us move open source silicon forward. Wait, are those for Linux? I don't know if I understand the question, so I'll have to skip it. Can you please share with us the list of recommended open source tools? That's both on the efabless.com site and also linked in the Chipalooza page. What EM tools do you recommend? And by EM, Gvidas, I think you mean electromigration. Is that the question, or is it something else? I'll have to wait till he clarifies.
Yeah, that could be referring to electric field solvers or electromigration.
Yeah.
The answer for electromigration is I don't think we have much, and that most of it is done by hand, hand calculation, which is generally possible on this scale of IP. It shouldn't be too hard to get a reasonable electromigration limit and know exactly how you need to size wires.
Is there a recommended field solver tool for EM for electromagnetic waves?
Yeah, I'm inclined to say ask that again on the Slack channel so that I have a chance to look up a few things. The one I like to use is FasterCap and Fast Henry from what is it called? fastfieldsolvers.com. But I know there's a few others that I've heard mentioned that people like. So there are at least 2, I think 3 good field solvers out there that are open source.
Okay, we are just over halfway through the questions and they're still coming in. In the spreadsheet, there are other blocks like programmable gain amplifier without details about them. Can we choose those blocks too?
There were some, a list on that summary page. I had moved all of the IPs that we decided that we were going to do for the challenge up to the top. The ones below, you can start thinking about them. We're not requesting proposals for those. Those are the sort of thing that may go out on another challenge.
Are workshops only for the accepted proposals?
I think we covered that before. No, the workshops will be open to anybody. And we hope everybody will come.
What tool do you recommend for parasitic extraction?
Right now, Magic is the only layout tool that does parasitic extraction.
In the open source.
Right, open source. So I recommend it.
Yep. Do we need specialized equipment to test the fabricated chips, or standard benchtop equipment would be enough? The answer is standard benchtop equipment. You should be able to test your design completely inside either a hosted environment hosted by eFabless or on your bench with a couple of Digilant? I can't remember who makes them, the ADKs.
Yeah,
the ADKs.
Digilant.
You may have trouble when it comes to the 16-bit 1 megasample SAR ADC, but the rest of the system should be very easy to test with that level of equipment. Yeah,
I have this written down, and I think there are some of the requirements that I posted to the Slack channel, but didn't put them in the slides here. But yeah, I said more or less the same thing, which is that we expect you to do some characterization, full functional verification of your circuit, do some characterization. When it comes to things like characterization over temperature, we don't expect you to have a temperature force unit. If you do, and you want to volunteer your time to do full temperature testing, that would be awesome. But it's not a requirement.
Yep. Is there a way we can contact people attending the meeting on the Slack channel for Chipalooza? If you want to create a team of people who are not currently teamed but might think about it, please just ping that channel and ask if anybody's interested in developing a team.
And likewise for any additional questions, because they keep coming in, I think we'll have to move questions and answers to the Slack channel as we're coming up on the end of the hour.
So we've got 26 answers. I'm trying to scroll really quickly to see super.
Just check for important ones that we can cover in the 1 minute. If everybody wants to stay on an extra minute.
There's a basic question. Can we please put up the links we mentioned? Andrea,
absolutely.
Can you, Tim? Can you just show people the Chipalooza Slack channel? And Andrea, have you already posted it in the webinar chat? I think Andrea posted it. I see it in the chat.
Yeah.
It is posted in the webinar chat channel to anybody who hasn't already found it. And there is an invite to it also posted up earlier in the webinar chat channel by Andrea. And that invite works. At least it certainly worked for me when I clicked on it. what are the supported formats for the output files? All of the supported formats are going to be based on open source data. So it'll be based on something that's possible to get in an open source tool. We can define that over the course of the next roughly 2 weeks. What's the general op-amp input voltage range? I can only see an output voltage range. That's the rail-to-rail or common mode input range question, Tim.
Which amplifier is that? Yeah, I should say, in addition to unreasonable specs, if you see missing specs, please let us know. I believe I got all of them, but I spent a lot of time quickly moving things around in the, 20 pages of specs over a short period of time. So if I missed something, just let me know.
Does Magic do RNC and CC extraction? Any options for that?
Yes, it does RNC and CC extraction.
Yep. Okay. I think that's probably as many as we can hit live, and we're 1 minute over. I think the others probably need to move, Andrea, with your help, to the Slack channel. Do you have all the, Andrea, are you able to collect all the unanswered questions for us and move them to the Slack?
Yep.
Fantastic. Thank you very much for attendance, for participation, and for the fantastic questions.
Yeah, it's been a great webinar. Appreciate you all coming. And as I said, I hope to see you in the challenge.